Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Let's look at the sixth question here. A circular wire of radius 7 centimeter is cut. Alright, so there is a circular wire of radius 7 centimeter. And what are you doing? You are cutting that circle of wire. Alright, so you get a length of wire in your hand. And then what do you do? And bend again into an arc of circle. Okay, so you make an arc of a circle. All right, not the full circle, but just an arc, because this is the wire you have got, and you are making an arc of radius 12 centimeter. All right, so here the radius is bigger. Here it is only 7 centimeter. Now you will get only so much of wire here. All right, only so much of wire, so you cannot complete the bigger circle here because the length of the wire does not change. So you cannot make a bigger circle, you can make just an arc of the circle. The angle subtended by the arc at the center is, so what you have to find is theta here. Well, now to find theta, what do you need? See, theta is L by R, that means arc length by radius. Radius is 12 centimeter, fine. So what about the arc length? So what is the length of the wire you have got? So that is the circumference of this circle. So if you know the radius, you can find the circumference, and that is the arc length of the arc. Alright, so we will find the arc length first, that means the circumference of this circle, and then we can find theta. So let's begin. So what am I finding? Circumference of the circle. So that is 2 pi r, now 2 and then pi, and the radius is 7 centimeter. So that is 14 into pi, so that is 22 by 7. So therefore that is 44 centimeters. So 44 centimeter is the circumference, and that is the arc length. So L is 44 centimeter. Now what are you going to find? Yes, theta. So find theta. See, we got the arc length, that is the circumference of that circle, and now we have to find theta. Radius is 12 centimeter. Okay, so radius is 12 centimeter and L is 44. Okay, so that is theta, that means it is 11 by 3 if you simplify by 4, right? And that is the radian, but we need it in degree, understand? So pi radian is 180 degree, therefore what about 11 by 3 radian? Correct. So cross multiply, so 11 by 3 into 180 divided by pi. So we have to get this in terms of degrees. All right, so simplify this. So when you simplify, replace this pi. Okay, so 11 into 180 divided by 3 into 22 by 7 pi. So what happens to this 7? Goes to the numerator, obviously. So into 7. So now this is 11 ones 2, correct, and then 3 2s are 6, so this will be 30. So 30 into 7, 210 degrees. Well, so 210 10 degrees. So how do you get it? See, this is 180 degree divided by 6 into 7. So this is 30. So 30 into 7, that is 210 degrees. So option B is the right answer for 6th question. So let's move to the 7th, which is very similar to the previous question. Okay, so the difference is the radius of the circle is 3 centimeter here, and the radius of the hoop, okay, the arc, is 48 centimeter. That's the only difference. You just have to replace the values there and you get the required answer. Let's see how it goes. So first you have got a circle of radius 3 centimeter, very small circle. Alright, so find the circumference of that, and then you have a hoop, okay, and the radius here is 48 centimeter. Alright, so what is the arc length? Okay, what is the length of the wire? That is the circumference of this circular wire. Correct. So when you cut it and then you open it, you get the wire and then you make the arc. Alright, that's how it works. So let's find the circumference. That is 2 pi r, and that means it is 2 pi into 3, so 6 pi. Alright, so 6 pi centimeters. Let's not substitute here. You can substitute and simplify, but let us keep it that way. So what is the arc length? L is 6 pi centimeter. Now find theta, the angle, okay, subtended at the center. That's the question asked here. So that is L by R. What is L? 6 pi divided by the radius 48. So that is pi by 8. Radian. Correct. So pi by 8, because theta, if you use the formula, the theta will be in terms of radian. Now the options are in terms of degrees, therefore convert it to degree. How? So understand. So you have got 180 degree is equal to pi radian. Now what you have got is pi by 8 radian. Therefore that is equal to how much? Cross multiply, that means pi by 8 into 180 divided by pi. Okay, so cancel it straight away. So 180 divided by 8, simplify by 4, so that is 45 degree divided by 2. So half of 45 is 22.5. So 22.5 degree is in the option C, therefore option C is the right choice for question number 7. Let's look at the question number 8. Now whenever you have a question based on a clock, remember the following things. Alright, so imagine you have a clock and then 4, 5 and 6 here, 7, 8 and 9 here, 10 and 11. You have the hour hand, you have the minute hand, right? So first understand only the hour hand. See, when you have it here, that's the original position, and then the hour hand is moving and it completes one full rotation. So when it completes the full rotation, how much angle is it making? So it is making 360 degree, correct? That means when you have 1 hour, 2 hour, 3, 4, 5, 6, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock and then 12 o'clock. So 12 to 12 o'clock. That means totally how many hours? 12 hours. So in 12 hours, how many degree, how much is the angle covered by that? So angle made by it is 360 or in radian 2 pi, correct? So 2 pi radian it is making. All right. Similarly, if you need for 1 hour, so for 1 hour, how much is it making? So for 1 hour, divide by 12, right? So 360 divided by 12 or 2 pi radian divided by 12. So what is it? So 12 ones are 12 threes are, so 30 or it is pi by 6 radian. So it is pi by 6 radian. So that's the angle made by the hour hand in 1 hour. That means from 12, if it is come to 1 o'clock, okay, from 12 o'clock to 1 o'clock, the angle made by the hour hand is 30 okay. So if it is 3 o'clock, so 12 to 3, so that is totally 90, correct? Now what about the minute hand? All right, so the minute hand, the larger hand, all right, the large hand, our hand is the smaller hand. Well, so how much angle is it making there? Okay, so first of all, in 12 hours it is 360. What about the minute hand? 5 minutes, 10 minutes, 15 minutes. So when it covers total circle, it will be 60 minutes, correct? So 60 minutes is 1 hour. So in 1 hour or 60 minutes, so what is the angle made by the minute hand? 360 or 2 pi radian. So this is the angle made by the minute hand in 1 hour. Okay, so 60 minutes. So for 1 minute, okay, so for 1 minute you have to divide by 60. Okay, so that is 360 divided by 60 or 2 pi radian divided by 60. Okay, so how much is it making? So that will be 6 degrees or it is pi by 30 radian. All right, so pi by 30 radian or 6 degrees is the angle made by the minute hand in 1 minute. So from here, if it is moving to 1 minute, it will be 6 degrees. All right, so if it is moving 60 minutes, then it will be 6 into 60, 360 degrees full circle. Well, so this is the calculation you should keep in mind if a question is based on a clock. Well, now look at the question number 8. The large hand of a clock is 42 centimeter long. Okay, now we are talking about only the larger hand. All right, and that is 42 centimeter long. That is the length. All right, now how much distance does it extremity? Extremity is the tip of the minute hand. So the tip of the minute hand is moving, okay, and it is moving, how much is it moving? It is making 20 minutes. All right, so it is making 20 minutes, and what you need to find is the length of the arc, all right, or the distance covered by the tip of the minute hand in 20 minutes. This is 42 centimeter long. What is this arc length? First find the angle. So if you know the angle theta, you can find L, because you have a relation theta is equal to L by R, correct, or L is equal to R theta. So L we have to find here. So before that we have to find theta. Understand, in 1 minute, 6 degrees. So for 20 minutes, what is the angle made by the minute hand? It is 20 into 6 degree, that is 120, or multiply by 20 here. So 0 cancels, 2 pi by 3 or 2 pi by 3 radian. So we got the angle here. Okay, so what is the angle? Angle is 2 pi by 3. Alright, so now find L. Understand theta is L by R, therefore L is R is multiplied to the other side, becomes R theta. Well, so therefore this is R theta. Radius is 42 centimeter and then theta is 2 pi by 3. So 2 pi by 3 is 60 degree. So 2 times 60, 120 degree. Well, now simplify this. So 3 ones, 3 14. So 2 into 14, 28 pi. Now replace this pi, 28 into 22 by 7. 7 ones, 7 fours, 4 into 22. So that is 88 centimeter. So 88 centimeter is in the first option. Therefore, the first option is the answer for question number 8. Well, so that completes 8. Now let's move to the next question. Let us look at the question number 9 here. This is about finding the ratio. All right, if the arcs of same lengths in two circles subtend angles 65 degree and 110 degree at the center, find the ratio of their radii. All right, so there are two circles of same arc length. All right, but the angles are different. You have to find the ratio of the radius. Okay, radii. That means the radii are not equal. So you have different circles here. All right, the radius are different. We'll take R1 and R2. Well, arc length are same. So you have let us say L, and here also we'll take L. So theta is different. So first is 65 degree. All right, second is 110 degree. All right, so we'll take theta 1 and here theta 2. All right, so we have to find the ratio between R1 and R2. So R1 is to R2, or in other words R1 divided by R2. This is what we have to find. So we have to find the ratio between R1 and R2. So which formula are we going to use here? The same formula, theta is equal to L by R, or R is equal to L by theta. Alright, so that's the formula we'll use. But before that, let us write what is theta 1. So theta 1 is 65 degree. Alright, so we have to convert that into radian. So pi by 180 degree. Alright, so simplify that and find. And similarly, you have got theta 2 110 degree, and once again convert that to radian. So what are you getting? Theta 1 as so theta 1 will be 13 pi by 36 here. All right, 13 pi by 36, and then theta 2 will be 22 pi by 36. So 22 pi by 36. So that is the angles. These are the angles in radian measure. Okay, you just have to multiply by pi by 180. You know that conversion, correct? So pi radian is equal to 180 degree. So use that conversion and then convert that degree measure into radian measure. Well, so that is done. We don't know what is R1 and R2. We don't know what is L. L is, I mean, both the arc length of the arc are equal. Okay, so arc lengths are equal here. and we'll use the formula now, and let's see how it goes. So what you know is theta is equal to L by R, therefore L is equal to R theta, correct. Now both the arc lengths are equal, so R1 into R theta, and that is equal to R2 into theta 2, because L is equal to R theta for the first formula. So L is equal to R1 theta 1, and here also L is equal to R2 into theta 2, correct. So those two are equal. Now therefore there is no role for L. Now what is R1 divided by R2? That R2 must be brought here. Theta 1 goes to the other side, so theta 2 divided by theta 1. So this is the values, these are the values we have to substitute, and hence we will find R1 by R2, or R1 is to R2. That's the way options are given. So substitute theta 2 first, please remember, don't write theta 1, alright. So here R1 by R2, yes, but theta 1 is moved here, so when you are moving it to the other side, it is coming in the denominator, okay. So theta 2 first, that means you have got 22 by pi divided by 36, and here you have got 13 pi by 36, cancel 22 by 13, that's it. So 22 is to 13 is the right answer, and that's in option C. Well, so that is about finding the ratio. Now let's move to the question number 10. In a circle of diameter 40 centimeter, a chord is of length 20 centimeter. So you have got a circle whose diameter is 40 centimeter. That means what is its radius? Half of the diameter, right? So that is 20 centimeter. So radius is 20 centimeter, and there is a chord of length 20 centimeter, okay, and the radius is also 20 centimeter. Therefore what is the angle subtended by the arc, all right, at the center? So this is the minor arc, all right. So this is the minor arc, and that is the major arc. So we are not asked to find the major arc, we are asked to find the length of the minor arc. So we have to find L. You know R, yes, radius, but do you know theta? No, we do not know just yet, but we will find. How are you going to find? Look at this, all the three sides are 20 centimeter. That means this is an equilateral triangle. So in an equilateral triangle, the angle is also equal. So 180 divided by 3, that is 60 degree. So since it is equilateral triangle, angle is 60 degree, which means it is you have to multiply and divide, okay, multiply by pi, divide by 180 degree. So that is 60, and this is 3 times, so pi by 3 radian. So pi by 3 radian is theta. Now find L. So what is L? L is equal to R theta, or theta is equal to L by R, in whichever way, whichever form you can remember it, okay. So just remember in one form, then you can get the other, okay. That's the way you can remember. Now R is 20 centimeter, so your arc length will also be in terms of centimeter, all right. Now theta is pi by 3, all right. So that's it, you don't have to do anything else. So options are in this way itself. So this is centimeter, so 20 pi by 3 centimeter, option A. You don't have to substitute pi there, because the options are given in terms of pi. Well, so that's it for questions based on the angle and the length of the arc and the relation between the angle, length of the arc and radius of the circle. So thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.